Okay, so I'm going to solve the first problem of the finite element Nastran patron of tutorial 3. So firstly, file, new, desktop, tutorial 3. So I'm going to, all right, so new folder, one, and the name at delivered .db as usual. Okay, so let's put this one here. Actually, this one here. Okay, so tolerance should be default. MSC Nastran is okay. Analysis should be structure. Okay. Now, starting with the geometry. Now, in the geometry, surface XYZ or object surface curve must be XYZ. And here it should be 5, 1, 0, the vector list. Then clicking on apply. Now, under home tab, we can click on the smooth shade, this guy. And from here, orientation, we can click on ISO 3 view. So you can see that. Okay, and we can put it back. So wireframe, this one. And it should be front view here. So we're going to mesh this plate. So meshing. So in the meshing part, meshing tab. So mesh, and in the measures, we will choose surface. So it will be this guy here, surface, or here, if I find here, mesh. So we can choose surface here, or in meshing, we can choose this surface here. All right. Now we will select as quadrant in element shape. Measure should stay in as it is. So mesh quadrant 4, it's okay. And now we can select surface 1 from viewport. So it's been saying like surface here. So can I move this one here? So if I move it this one, Okay, let's leave it this one here. All right, surface here. Then here surface 1 in surface list. Then we will click on apply. So we see some structure like this. So again, home, manage sky, so we can see that. So home, XYZ. Okay. Now we're going to create the force. So what we're gonna do is under home, we will click on model tree. So here we click on anything, right click, then we create LBC, or we can choose just on here in load. So we can choose here or here, just create LBC. Now here in this one here, force as object type is just force is going to be in just one point here. Now let's call this one force 1, input data, and this will be 0. The other one, the third one will be -8. So just two of them 0. And click OK. Then we will select region, then finite element as here. So instead of geometry, I'll choose FEM. Now, for here, I will pick all for the way that we choose everything. I will put not pick all, just node. And this point should be only this point. Dot. Add. OK. Apply. And you should see something like this. All right. Now, we got this one. So we're going to create the displacement. Now again, right click on this, create, and then LBC, and displacement, nodal as type. Then here, what we can call this one, displacement 1, input, and everything will be 0, 0. Apply. Actually, I should choose this. So I will choose here. So I'll choose FEM. So actually I will choose geometry, and here I will choose curve here. Okay. I will choose this guy here. So, okay. So this one is chosen here. Add. So I'm not sure. So can I remove this one? All right. So here, curve. and I will choose this guy only. Add, okay, apply, yes, or no, it's okay now. So this time, can I have shade? Yeah, so you see this part here and here. All right, it should be like this. Okay, now we're going to have uh, the material. So again, properties here, or right click on here, then create material. So the isotropic will appear here automatically. So first one, aluminum. Okay, input properties, and elastic modulus is 10 power 7. 10 times 10 power 6. E Poisson ratio is 3. Okay, so apply. Now here, now we are going to impose this feature, this material to our shape. So again, right click on here, create property. So action will be again create, object will be 2D, type will stay in shell. So the name, aluminum plate, input properties, this guy, the material name we can choose here, aluminum. The thickness is 0.1. Okay, and now select region here. So here I will pick all here I should find the pick all. So I presume that pick all here. Okay, add. Okay. Now from here, uh, yeah, everything is okay now. All right. So we got the material has been imposed to all of the uh, elements here. Now we're going to check that the loads and displacement like have been applied. Okay, so for this one, to show all the load case, so we go here. Okay, so we got this one already. So now here, load cases. So what I'm gonna do is clicking on this, and I can see the input data here. Or I can just right click on this and show this one, and I see the displacement one and force one here. Okay, and no need to do anything else. Now we're going to run the analysis. So what I can do is just I can choose this guy here, analysis, but this time we're interested just using the model tree here. So again, right click on any item. So create. Okay, create, actually, analyze. Okay, so everything is fine. Action, object, method, and the solution type should be in linear, all right, which is, it is here, you see linear static. Okay, and apply. So Nastran will start to solve this uh, finite element question. Okay, so here now for this one, we don't need to do anything else here. In action, access results, attach HDF5. All right, everything is fine. Select result file, and I click on cantilever plate. Okay. Then I will press apply. Okay, so, all right. Now, let's go to the result. Okay. Again, on any item, right click, create, and we will choose result here. Okay. So we will choose a quick plot. We don't need to be worried about this guy here. Now, in the for select deformation result, I will choose this one. In case you clicked on this one, by clicking again, it will deselect that one. Displacement translational, apply, and we will see the desired result, which is compatible on the tutorial PDF. And we can continue this one. So select stress tensor, displacement translational here, and we can, so quantity needs to be changed, and this will be X component, apply, and we can see the result.